0.6, so we're under that 1.8 CFS requirement, okay? And the peak elevation in the system is 102.66, okay? So we have some flow, you can see in the primary 0.6, we have some flow that is going out of the upper orifice, okay? And this is our sizing of that. It was a 12-inch by 6-inch vertical orifice to get that number. So here's our routing. If you have soil tests that say that you have infiltration occurring, you can add the infiltration component into this routing as well and take the volume that's being taken through the infiltration occurring as well. So if I look at, so this system goes up to 102.66. From 102.66 to that first orifice at 102.35, that water's going to drain right out, right out through the orifice. So then what's left is the volume at 102.35 minus the volume that's at the 102.00, which in our case is 8,400. So the volume that you have to dewater to get that ponding depth back down to 0 is the 12,848 that you get here, minus the 8,400, which is the volume at the top of the soil. So you have 4,448 cubic feet of water that's open ponded water. Divide that by the 0.02 CFS, multiply it by to get it to hours, and you can see that time took 61 hours, which is less than the 72. Okay? So you can see it, if you have too much volume in the ponded area and you have a very small orifice, you're not going to be able to drain this thing in 72 hours. Okay, so then the volume managed is this number right here, 12,848, okay? And which is at that, and the geomorphic volume is the 12,848 minus the 6396, which is 6452. Okay? So that's a simplified example. It's pretty straightforward. Like I said, the other place we're kind of starting to see this is if we have questionable basins that really aren't draining, we could ask somebody to look at this concept as a retrofit too, because this will allow you to basically slowly release the water from that basin and get it to drain. So, any questions? Yes, ma'am.
Maybe I just missed it. The media depth and the IWS depth, are they equal to each other, or is there a requirement between the two?
No. The question is the IWS and how are the IWS and the media depth related? So the IWS only has to be 1 foot minimum. The media depth, which includes the IWS, is 2 foot minimum. So you could, and it could go up to 4 feet. So you could have an IWS that's 1 foot and then 3 feet of soil. You could have an IWS of 2 feet of soil and then 2 feet of that. The big thing is the IWS has to be assumed to be half saturated. So whatever you claim as the IWS, you only get the 15% voids for determining the volume in that IWS, as opposed to the media depth where you get the full 30%. Okay? Does that answer your question? Anybody else? In the back?
Tell us a little bit about the media. What are the standards for that?
The what?
The standards for the media?
Well, the standards for the media should be similar to the soil amendments that you're doing in rain gardens or what you're doing to remediate the soils to get them to infiltrate. The requirement is, and we would require post-installation testing, is that it meets that 0.2 inches to 10 inch an hour that's recommended in the MPDS manual. So again, if you're having issues with on-site soils, you probably want to bring in some kind of sand mixture, kind of thin out the mix, so to speak, to get a better infiltration rate through that IWS and through that soil media. Yes?
Can you comment on the potential for clogging of your underdrain system over time?
Well, that could be an issue. That's why, you would have to look at, do you have an adequate gravel bed? The question is clogging of the underdrain system over time. I think if you would need some kind of separation fabric in there, That's why we also like the idea of that you bring the under drain into the inlet box, which is usually your control structure, and turn it up and cap it, because now you have a way to flush the system out as well for that. So yeah, that could be a potential issue long-term over time. That would be something that you would want to address in your operation and maintenance requirements, you know, for the BMP. Yes.
Yeah, was the underground drainage outlet to the existing ground?
Say that again?
Does the underground drainage go to existing ground?
Well, the underdrain itself, does that go to existing ground? Yeah, it would be like a conventional basin where you would then have the underdrain goes into the box, and then you would have some kind of discharge from the box, usually a pipe, that would then discharge to a drainage swale or to a surface water. Does that answer your question?
Not really.
Oh, can you give me?
It goes, the elbow out goes to a box then?
Yes, usually the elbow out, the underdrain, so the underdrain comes into the box, it turns up 1 foot.
Yeah.
Okay, then it has an orifice opening or some control opening to meet this .01 CFS. Then once it comes out of that box, it would go into a regular storm pipe or whatever your conventional outlet pipe is from your control structure. Okay?
Maybe go back to the illustration, that might help.
Yeah. So they don't show a control box here. I think in most cases you would want to, as we said, you would want to turn this under drain and put it into an inlet box or some other kind of control structure that's controlling all the overflow and everything happening here, just to keep that, to keep it clean. And like we were talking about clogging and maintenance issues, that would probably be the cleanest way to do it instead of trying to run this thing like straight out and discharge it to grade. Because you're going to have to provide some kind of overflow anyway. Again, depending on what you have. If you're using this as in a rate control basin, you're going to have some kind of outlet control structure anyway there in that case. Anything else? Yes?
Using media under the parking scares me a little bit.
Using what?
Using the media under the parking scares me a little bit.
That could,
The fabric inside that helps, but I wonder what that'll look like in 10 years. And do you have any suggestions?
well, and again, if you're using, I think if you're going underground, it would be probably wise to just do a straight gravel system or a gravel system with storage chambers. You can still take credit. You wouldn't get the IWS credit for volume removed, but you would get the credit that would happen for the water that's going through the underdrain and the volume that's discharged through the underdrain. And then potentially an infiltration component. When you have an IWS under an underground system, it's usually existing soils that are below that underdrain. You're usually not modifying, and you're usually not putting soils above the underdrain in that case and below the pavement. So, yes.
Have you guys approved any of these concepts?
Yes, we have.
What types have you seen, the open or?
We've seen open, we've seen an open retrofit that they did, and actually in that case their basin got smaller and they were able to put the amended soils on top of the bottom of the basin in that case without having to excavate. Drew, what did you see? Was yours an open? You've seen both? Yeah, I think we've had 3 total that have come in so far, 1 retrofit and 2 new. 2 above ground and 1 below ground is what we've seen so far. Any other questions? Yes?
I just wondered, what's the benefit to use the upturn elbow? Can you run the underdrain above the internal water storage?
No, the point is that the question is, can you run this under drain at this level? Okay, And the question is, no, the purpose is so that this water stays in, and you get the filtering component, and you get the ET component working in this case, okay? If you just did this, that you would be relying totally, you know, the system is designed so that this sits at the bottom and then it goes through that filtering before it goes out and it's pushed out through the head pressure. Anything else? Other questions? No? Okay, thank you.